So today we are going to do page 7 and 8, and I thought that it's important to use the color calculator, so I am trying out a new calculator. A little bit harder to use. I'm not getting used to it, so excuse me if I make some wrong button pushes here. So let's go to page or number 1 and see if we can do this as painlessly as possible. So again, these problems are challenging because we're working with two different functions. One of the functions is the function they give you. So first they tell us that point P lies on the curve y equals blah, blah, blah. We're going to mark that blue because that's the principal function. The gradient of the curve at P is equal to 7. So what they're kind of giving us is the numbered tile that we put on top of the curve saying what the slope is at every single point, right? So it turns out that point P has a slope of 7. Find the gradient function of the curve. Okay, so the gradient function of the curve we're going to find by taking the derivative of the blue function. So it's going to be the red function, which is the derivative of the blue function. So the gradient function is y dash, and we're going to take the derivative of the first term, 2x squared, the derivative is 2x. The second term is 3x, the derivative is 3. And the derivative of the fourth term, negative 4, is just 0. So our gradient function, which is the red function, is 2x plus 3. Okay, and then what the first thing we're always going to do is, once we get the derivative, is we're going to put the blue function and the red function in the calculator. Now you can see why I made the blue function blue and the red function red, because that is the automatic color coding that the color calculators give it. So the blue function is x squared plus 3x minus 4. I'm going to put that in the calculator. So x squared plus 3x plus or minus 4. And then the red function is 2x plus 3. Oops, not 2 times, it's 2x plus 3. And I'm not going to graph these functions. I'm only going to look at the table, okay? I'm going to look at the table. And then I can see that the blue function is in blue and the red function is in red, so the slopes are in red. So it tells me that at point P, the gradient is 7. And so if I find the red 7, which I found right here, then I know that the point P is 2, 6. Okay? So at 2, 6, the slope is 7. And you can see that easily on this chart, right? On this table. So the x-coordinate and the y-coordinate of P are basically 2, 6. And we can see that easily here. And I'm going to write that answer in blue because that's the blue function. And I'm just going to show you the graph so that you can see what it looks like. But the graph is sometimes a little bit confusing to people because especially when you put both of them on the same grid, it's like, okay, what's what here? So I'm going to just show you the answer is 2, 6. 2, 6 is this point right here, right? So at this point right here, the slope happens to be 7. Okay, and how can we see that? Because the red function has a height of 7 at that point. But I think that's a little bit confusing. So I prefer just to show you the table, and you look at the table and you say, okay, I'm looking for the red 7. The point is 2, 6. They ask for the x-coordinate, it would be 2. The y-coordinate, 6. Okay? So that is the way you do it totally with the calculator and with as little algebra as possible. Now let's go to number 3. If you would like to see how to do it with algebra, I have another video which shows you how to do it with algebra. Okay? So number 3, it says that the curve has the blue function, which is the original function, is 4 plus 3x minus x squared, and the gradient of the curve at r is equal to negative 3. Find the gradient function of the curve. So again, we want to find the red function. The way we find the red function is we do derivative of 4 is 0, derivative of 3x is 3, derivative of negative x squared is negative 2x. Now we're going to put both functions into the calculator. So we're going to put 4 plus 3x. Oh, let's clear this. 4 plus 3x minus x squared. And in the red function, we're going to put 3 minus 2x. Okay? And then we're going to look at the table. And we're going to find when the gradient is equal to -3, and that would be point R. And then we would be able to find point R. Oh, there it is. There's -3 right there. So the point that has a gradient of -3 is 3, 4. So I'm going to put the answer in blue because it's part of the blue function. So 3, 4 is A, B. So A is 3 and B is 4. Wasn't that easy? Okay, and not too confusing, right? You just got to keep it straight here. They're giving you the blue curve and you want to find the red curve. The red curve corresponds to the gradients or the slopes of the blue function. So it says find the coordinates of the point on the curve, which the gradient of the curve is 4. So first we're going to find the derivative function, which is a red function, right? 6x plus 1, and then the derivative of -5 is 0. So the derivative of 3x squared plus x is 6x plus 1, right? And then we're going to program both of those into the calculator. So the first one is going to be 3x squared. Oops, I got to clear this. 3x squared plus x minus 5. And the red function, we know it's the red function because it's here. Sorry for you guys that don't have the newest calculators or color, but you can kind of imagine what's going on, right? The first function is the blue function. The second function is the red function. So just, always be thinking about that when you look at your charts. So here, if I want to find when the gradient is 4, I'm looking for the red 4, and I don't see any. So this is going to be a tricky one, isn't it? Now, you remember the tricks we would use to find when the red 4 would occur? For example, do you see that the red 4 probably occurs between the 1 and the 7, right? So what we can do is we could put the cursor on the line that's 1, and then we could increase the step size, right? So let's increase the step, or like decrease the step size. So we're going to make the step size 0.01, and then we're going to try to find when now the red function gets to a value of 4. Let's see if we can. We're getting warmer. Oh, we're very close now. There it is. Oh, we didn't even probably need to do a step size of 0.01. A step size of 0.1 would have been fine, right? Let's see. If we would have done a step size of 0.1, we would have found it much quicker maybe. Do you see? So when x is 0.5, we get red 4, right? So what would be the coordinates of the point where the slope is 4? It would be 0.5. I'm going to put it in blue. Be 0.5 comma -3.75, right? 0.5 comma -3.75. Okay, let's go to the next one. So the next one, the blue curve, would be this. And it says there are 2 points on the curve where the gradient is 6. And remember, the gradient of 6, that would be a red 6 that we're looking for. So let's program in the calculator the two functions. The first function is x squared plus 3x. Oh, I forgot to do the derivative. Let me do that first. So x squared plus 3x plus 4. Of course, you're going to remember when you're like, okay, what's my next function to put in? My next function is going to be the red function. It's going to be, oh, it's not x squared. I'm sorry, my vision, even with my glasses, is not that good right now. Okay, 3. Like small numbers, it's hard to see. 3x squared would be the derivative of the first term. Second term is plus 3x, the derivative is plus 3, and the derivative of plus 4, of course, is just 0. 3x squared plus 3 is the red function, right? Now I'm going to look at the table. And, oh, I forgot to reset it back to step size of +1. So let me show you the good way to do that. You go second table set, and then you change table start to 0, and then you change delta table to 1, and then that'll be like the way it'll be. That's the way it is normally. Okay, now we're looking for when is the gradient of the curve 6, and we're expecting to see 2 places. I can already see 1. 1 comma 8 is one of the points. Let's go up a little bit. See, there it is. There's one here and there's one here. So one of the points would be negative 1 comma 0, and we'll put that in blue. And the other point would be 1 comma 8. Okay, so those are the 2 points that have a red 6 or a slope of 6. Okay, so we're already done with page 7. Let's move on to page 8. Okay, similar problems here. Okay, so this one, the blue curve is this one, says it's looking for when the gradient of the curve is 0, and there's going to be 2 points that have that. Okay, and so first what we're going to do is we're going to find these 2 points. And in order to do that, we're going to have to take the derivative. And let's see, derivative of x cubed is 3x squared. The derivative of minus 12x is minus 12. And the derivative of plus 5 is just 0. So now I'm going to put the blue function and the red function in the calculator. So we're going to have x cubed minus 12x plus 5. And the red function is going to be 3x squared minus 12. 3x squared, oops, forgot to clear this. 3x squared minus 12. And then I'm going to do second table. And I'm going to look for when the gradient is 0. And there's 2 points you can see. There's a point here, negative 221, and there's a point here, 2 comma negative 11. So one of the points would be negative 2 comma 21, and the other point would be 2 comma negative 11. And these are the 2 points. These are the 2 points that have a slope of 0. Then it says to find the equation of a straight line that passes through these 2 points, okay? So now we're going back a few chapters ago, okay? And do you remember how to find a line that goes through 2 points like that with the calculator? It's very easy. You go stat edit. You just do a linear regression between the 2 points. So we're going to put negative 2, 2, and the y coordinates are 21 and negative 11. Right? All right, and then we're going to draw a line through those, and the way we do that is we do stat calc lin reg ax plus b. Okay, and we put L1, L2 there. We go down to calculate, and it's going to perfectly draw a line through those points, and the equation of the line is y equals negative, oh my gosh. I think that was my umbrella that dropped, don't worry. Negative x plus 5. Okay? And let's go to number 11. So number 11. So it says there's a point which lies on the curve y equals x squared minus 3x minus 3. And this is our blue curve, of course. Find the value of b. Okay, now immediately after that, they're going to ask for the gradient function. But before that, we don't really need the gradient function to do the first part, which is they just want to see what the y value is when the x value is 5. So let's put in the blue function. It's x squared minus 3x minus 3. Okay, and then we're going to look at the table. And it says the point 5 comma something. What is the something? So 5 comma something, the something is 7. So the value of b happens to be 7. Okay. Now it says to find the gradient function of the curve, we need to take the derivative. So the derivative of that would be y dash equals 2x minus 3. So the red function is going to be 2x minus 3. And then we're going to look at the table. And then it's going to ask us, show that at P, the gradient of the curve is also equal to B. Okay, so we know that at point P, it's 5, 7, right? So let's go down to 5, 7 in blue. And then we can see that by coincidence, the slope at that point is red 7. So yeah, it is 7, okay? Now they asked us to show that. So in order to show that with arithmetic or with algebra, what we need to do is we need to substitute in the x equals 5 into this red equation, okay? So we'll do that because that's what they're asking for. So 2 times 5 minus 3, they want us to do the substitution there. 10 minus 3 is 7. So that's how we demonstrate, or we show that the red equation does give us 7 at that point by substituting in the x value of 5, we put it into the red equation and that gives us 7, okay? So, and that's all the calculator is doing, right? When it makes this column of numbers in red, it's putting every single possible red x value in here, and it's getting the red values of the slope, right? Okay, D. So the point Q is the point on the curve at which the gradient of the curve is equal to -3. Show that D is also equal to -3. Okay, so if we look through here and we try to find the red -3, it's right there. So the point Q is actually equal to 0, -3, right? And so we know that x equals 0 and y equals -3 in this case. The red slope that's associated with it is also -3. Now it asks us to show that. So how could we show that? The way we would show that is we would say, okay, so this is the point, right? 0, -3. So we can put the x value of 0 into the red equation, and that would give us -3 for the gradient. So we've shown that the gradient is -3, and we have shown that the y value of this point is also -3. Okay? Now, the way they probably wanted you to do that, complete with algebra, is they wanted you to first say, okay, first what I'm going to do is I'm going to take the red function, y dash equals 2x minus 3, and I'm going to set that equal to -3. And when I do that, I can see that 2x, if I add 3 to both sides, is equal to 0. So x equals 0. Once I show that x equals to 0, then I can go back and put it into the blue equation. And the blue equation is x squared minus 3x minus 3. I could put in 0 squared minus 3 times 0 minus 3, and I could see that the blue y value is going to be -3 in that case. And so then I say, okay, -3 red, -3 blue. It matches what they said. Okay? All right. 13. Consider the function, the blue function, 2x squared minus x plus 1. Okay, first it asks us to take the derivative, so we're going to do that. The derivative of this function is equal to 4x minus 1. Right? So if we put these in the calculator, we're going to put the blue function, which is 2x squared minus x plus 1. And the red function is 4x minus 1. And so if we look at the table of these, we'll see that at x equals 2, f of 2 equals 7, and the derivative function at 2 is also equal to 7. Okay, that's what we see from this row here. X equals 2, blue 7, red 7. So blue 7 means f of 2 equals 7. Red 7 means f dash of 2 equals 7. The derivative at x equals 2 equals 7. Okay? We could do that by hand or with arithmetic if we said y dash equals 4 times 2, which is x equals 2, minus 1, that would be 7. So that's how we would get it by hand, and the calculator is automatically doing that. Now C says, find the coordinates of a second point on the curve the blue curve, for which f is equal to f dash. So now what we can do is we can just look down the row and see if we see other values that are the same. And like here, I don't see any blue and red values that are the same and not even close, right? What about here? It's getting a little bit closer, and here it's kind of close, but let's see. No, I don't really see anything that's close here either. 7, 16, 11. Are they getting closer at any point? No, they're just getting farther apart, aren't they? They're just getting farther apart. Okay, now if I look at the graph at this point, it might help me figure out where the blue and the red values hit the same value. Shall we look at the graph? There's blue. There's red. Oh, do you see? They're the same at two different points. They're the same here, and they're the same here. Now, the value that we saw that was the same was this point here at x equals 2. What's this point here, I wonder? Okay, so we can see that between x equals 0 and 1, the red and the blue curves are the same also. I'm going to go back to the grid, because the table, because that's, one of the easiest places to see. So let's look between 0 and 1, and we're just going to increase the step size to 0.1, and we'll see if we can see any point that is the same. And we can. See, at x equals 0.5, blue and red are both the same. Okay, so the other point, the second point where f dash, or f and f dash are the same, is x equals 0.5 and y equals 1. And at that point, the derivative is also 1. Okay? All right, let's go to the next one. Number 15. Consider the function 2x squared minus x minus 1. First, do the derivative. So the derivative of that is going to be, and they're using, I'm using y dash, but since they're using f here, why don't we use the notation f dash? So f dash of x, which is also the derivative, is equal to 4x minus 1. Now we're going to do the second part, which is find the coordinates of the point of the curve y equals f of x, for which the derivative and the function have the same value. Okay, so it's very similar to the last problem. So the function is 2x squared minus x minus 1. And the red function is 4x minus 1, just like it's exactly like before, isn't it? And then we're going to do the table. And then we're going to check, oh, remember how I forgot to reset the table? So let's reset the table. Second table set, 0. This is a very handy procedure for you to know. And then I'm going to go back and look at the table. And let's see. Oh, there you go. Look, there's a point where both the blue and the red function have the same value of -1. Find the coordinates of the points on the curve. So this is one of the points on the curve. So let's write that point on the curve. So one of the points is 0, -1. Okay, 0, -1. And then we're looking for one other point where the blue and the red are equal to each other. Okay, and I don't see any right now. But let's go back to here and see if there's any points around here that are close. I am going to do a increase the step or decrease the step size to 0.1. See if we see any other matches, or if we see any points that might be close. So let's see. Here, I don't see any close calls. Don't see any here. So there's the match that we already saw. And, oh, maybe they're getting closer here. Maybe they're getting closer. Oh, I think the blue's catching up. Oh, there you go. So at 2.5 comma 9, there's another match, isn't there? Okay, so we have found a second coordinate where the blue and the red functions match. Okay, I don't think there's too many problems on the IB exam where they do this particular exercise, but it's easy to do, as you can see, right? Let's do the last one. It does really test your understanding of what the blue and the red function are, though, when they ask you this question. So there's the blue function. Find the coordinates of the point on the curve, f of x, for which the derivative and the original function are the same. So first what we're going to do is we're going to figure out what the derivative function is. Taking the derivative, it's 2x plus 4. We're going to put that in the calculator. So it's going to be x squared plus 4x, x squared, oops, let's clear, x squared plus 4x minus 1. Oh, x plus 4, plus 5. X squared plus 4x plus 5. And then we're going to put in the derivative 2x plus 4. And we're going to look at the grid, or look at the table. Oh, and I forgot again to put it back to normal. So table set 0, 1. Look at the table again. Okay, so now we're looking for the coordinates of the point. So there's only one point where they match. Let's see, oh, there we go, -1, 2. So at the point -1, 2, the red function is also 2, just like the blue function is 2. Okay, so that was it for page 8.